Good morning, students. So let's start our class today. First I want to discuss the 5, questions I gave yesterday. So all of you able to do all these 5 questions, or you have any doubt in any of these questions?
Sir, I had the doubt in fourth one.
Yeah, Divanshu, please come again once more.
Sir, I had doubt in the fourth question.
Okay. Okay.
Yes, even I
Okay. Sure. Definitely, we'll discuss. So let me first place the first question and let me understand whether all of you understood it correctly or not. So I hope I hope all of you are able to view the screen very clearly, right?
Yes, sir.
Okay. So this question is answered by everyone.
Yes.
Okay, great.
Yes, sir.
Then let me come to the second question. This was the second question, dear students. Correct?
Yes.
Yes, sir.
And
But
all
sir,
of you are able to do this thing?
sir, I didn't get it.
Okay. Let's discuss. So question here is that there are, 2n plus 1 terms in an arithmetic progression. If there are 2n plus 1 in an arithmetic progression, then prove that the ratio of the sum of the odd terms to the sum of the even terms is n plus 1 is to n. So how to proceed this one? So, the first and foremost thing, dear students, is that first we need to, consider that, okay, let's assume the first term be a, correct, no?
Yes.
Let's consider the first term is equal to a, and common difference is equal to d. Correct, no, dear students?
Yes.
Then what we get out of it? That, let's take, the two sums, sum of the odd terms. Okay. And there are 2n plus 1 terms. So if you see, according to the question, there are 2n plus 1 terms. So what is the sequence is becoming? It is, it something like that, t1 plus t2, t1, t2, t3. These are the, arithmetic progression. No?
Yeah.
What is that arithmetic progression? Arithmetic progression is something like this. T1. Okay, I think someone joined now. Okay, all right. Yeah. So it is T1, comma, T2, comma, T3, comma, T4. In that way, it goes up to T 2n plus 1, because there are 2n plus 1 terms, no?
Yes.
And 2n plus 1 is what, dear students? 2n plus 1 is an odd term, as that's why we wrote that 2n plus 1, no?
Yeah.
Now, according to the question, the sum of the odd terms. So let's take S1. S1 is equal to sum of the odd terms. Sum of the odd terms. Correct? Now, if it is a sum of the odd terms, so what it looks like? It looks like T1 plus T3 plus T5. In that way, it will continue till 2n plus 1. Isn't it, dear students?
Yeah.
Correct or not? So how many terms are there? Can someone tell me? If there are 2n plus 1 terms, then how many odd terms will be there in between? Are you getting my point, what I'm talking about?
So n plus 1.
Fantastic. It is n plus 1, isn't it? Just take a small example. Suppose let's take T1, T2, T3. 3 terms. How many odd terms are there? 2, no?
2, yeah. That's 3 times.
Similarly, you take T1, T2, T3, T4, T5. That is where n is equal to 2. 2 into 2 plus 1. How many odd terms are there? 3. T1, T3, and T5. Got it, no?
Yes.
So we see there are n plus 1 terms. So from here, what we can write? From here, we can write equal S1 is equal to n plus 1 by 2 into, that is the first term, that is T1, and the last term T2n plus 1. We learned this formula earlier, correct?
Yeah.
Once you know the entire terms of that, first term and last term and the common difference, okay, first term and last term if we know, and how many terms are there if we know, then we can find the sum of that arithmetic progression, correct or not?
Yes.
So now we can write it is that n plus 1 by 2. If you recall, what is T1? T1, according to our assumption, T1 is A.
A.
And what is T2n plus 1? It is A plus 2n plus 1 minus 1 into D. Correct or not?
Yes.
Clear or not clear?
Yes.
So this implies from here, what is the value of S1 we are going to get? The value of S1 we are going to get is that n plus 1 into A plus ND.
Yeah.
Correct or not? N plus 1 into A plus ND. Clear or not clear?
Yes.
Okay. Now, what we are going to find? We are going to find the S2, the sum of the even terms. In the same manner, you can find the sum of the even terms. So if we assume, let me use a different color. So what we are doing, S2 is equal to sum of the even terms. Correct, no, dear students?
Yes.
That is equal to what? It is equal to T2 plus T4 plus T6 up to T2n. T2 plus T4 plus T6 plus T2n. So this implies, now how many even terms are there? Even terms are already found n plus 1 odd terms, and as there are total number of terms is 2n plus 1, so definitely there should be n even terms, na? Mohor, did you get the point?
Yes. Yes.
So that should be n by 2. It is T2 plus T2n. Correct or not? So that is equal to n by 2 into what is T2? T2 is A plus D, na? 2 minus 1 into D. Correct or not? And what is T2n? A plus 2n minus 1 into D. Correct or not?
Yes.
So then what we'll get? What we'll get is that n into A plus nd. If you simplify further, dear students, S2 is equal to n into A plus nd. Correct? So now what is our question? According to the question, we need to find that S1 by S2. Correct or not? S1 by S2. So that is equal to n plus 1 into A plus nd divided by n into A plus nd. And from here, we find S1 is to S2 is equal to n plus 1 is to n, since a plus nd is not equal to 0. Correct or not? Absolutely. Yep.
And so could you explain once more, like how the sum of even, like number of even terms is n?
Okay, absolutely. Thanks for asking this question. So let's take, there are three terms, T1, T2, T3. How many odd terms are there?
2.
2, correct? So how we can express T1, T2, T3 in terms of 2n plus 1? It is 2 into 1 plus 1, where n equal to 1, no?
Yes.
This is n. This stands for, this is symbolic representation of n. So we get 2 odd terms, no?
Yes.
Odd means what? 1 plus 1, that is n plus 1.
Yes.
Now let's take 3 terms, T1, T2, T3, T4, T5, 5 terms. So this a representation is 2 into 2 plus 1, no?
Yes.
This is n, correct?
Yeah.
Then how many odd terms are there? Just by inspection, T1, T2, T3, T4, T5.
3. Yeah.
So that is 2 plus 1.
Yeah. Okay.
Correct, no?
Yes. Got it.
Or in very simple terms, what the explanation I have given, without that also you can say is that if there are total, 2n plus 1, 1, 2, 3 up to 2n plus 1, how many are odd and how many are even? Obviously, n plus 1 is odd, n plus 1 odd terms and n is even terms, correct, no?
Yes.
Okay. If this is clear, can you proceed to the, next question?
Yes.
The next question, what I gave, dear students, is something like this: that if in an AP the sum of the n terms is equal to n, and sum of the m terms is equal to the sum of the n terms, then prove that the m plus n terms is sum of its m plus n term is 0. Let me put it back here. Actually. Let me bring the question here, then we will discuss. This is the question I gave, dear students.
Yes.
Correct. So all of you are able to do it or not?
Yes, sir. I got it.
Yes, sir, I got this one.
Okay, great. Disha, Gurman, Sagnik, Srijita.
Yes, sir.
Okay. All right. Good. Fine then. Okay. So now let me proceed to the next question. Okay, so this was the next question, dear students.
Yes.
So how many of you are not yet to do it, or all of you got it?
I didn't get it.
Even I didn't get it.
Okay. We'll discuss this thing. Sagnik, Disha, Srijita, what about you?
I didn't get it.
Okay, no one got it. So let me see whether I give the question correct or not. If the sum of the first p terms of an AP is equal to the sum of their next q terms, or the sum of or the next odd terms, prove that p plus q into 1 by p minus 1 by r is equal to p plus r into 1 by p minus 1 by q. Okay, let's discuss this thing. So how to proceed? Very good question. See, the way to proceed is that always first you need to assume that is what is the first term and what is the common difference. Correct, no?
Yes.
So let's take A be the first term and D be the common difference. Correct, no, dear students? Okay. That our convention, according to the convention, let A be the first term and D be the common difference. Then, according to the question, the sum of first P terms is equal to sum of the next Q terms. Correct, no? So let's assume that the arithmetic progression is something like this: T1, T2, T3, T4, and so on. This is our arithmetic progression. Dear students, please see the way I'm solving it. And you also self-analyze that where things went wrong and where you got stuck. That is very important. So the sum of the P terms is equal to sum of the next Q terms, correct?
Yes.
Sum of the first P terms is equal to sum of the next Q terms. Sum of the next Q term. That next is an important word here. Next Q terms. So from here, what we are going to get? T1 plus T2 plus T3. In that way, if we go till Tp is equal to T of P plus 1, correct or not? Plus T of P plus 2. Are you getting my point, dear students? Plus
Yeah.
T of P plus 3 plus T of P plus Q, correct or not? Sum of the next Q terms. Anyone has any doubt? Sum of the first P terms. Let's take P equal to 5. So sum of the first 5 terms will be what? T1 plus T2 plus T3 plus T4 plus T5, na, dear students?
Yes.
And according to the question, that is equal to the sum of the next Q term. Next means after 5. Suppose that is equal to the sum of the next 9 terms. That means what? 6th term, 7th term, 8th term, and 9th term sum is equal to that T1 plus T2 plus T3 plus T4 plus T5. Correct, no?
Yes.
That is quite straightforward to understand. So then what we can write here? We are adding both sides T1 plus T2 plus T3 up to T5. So left hand side what we'll get? 2 into T1 plus T2 plus T3 up to T5. Sorry, not T5. I made a mistake. TP is equal to 2 into, sorry, not 2 into, it should be equal to T1 plus T2 plus T3 up to T plus P plus Q, na, dear students? All of you got the point or not? In the left hand side, I am adding T1 plus T2 plus T3 up to TP. Right hand side, I will also add na, T1 plus T2 plus T3 up to TP.
Yes.
Then TP plus 1, TP plus 2 is already there. So that means it is exactly meaning is that T1 plus T2 plus T3 up to TP plus Q, na?
Yes.
Okay. I am not repeating that everyone, whether you understood or not, but I hope you got it, right?
Yes.
So, so from here what we get? 2 into SP. So sum of the first P terms is equal to S of P plus Q, the sum of the P plus Q terms. Now let's apply the formula. So what is the formula? 2 into sum of the first P terms. If you apply the formula, P by 2 into twice A plus
P minus 1.
P minus 1 into D. That should be equal to P plus Q by 2 P plus Q by 2 into twice A plus P plus Q minus 1 into D. Correct or not? Anyone has any doubt, please ask me. So from here what we get? From here we get is that 2P by P plus Q. So from this one we get 2P by P plus Q is equal to 2A plus P plus Q minus 1 into D. 2A plus P plus Q minus 1 into D divided by 2A plus P minus 1 into D. Now we need to make little bit of, manipulation. Okay, manipulation in the sense is that what is our target? Our target is that we need to prove that P plus Q into 1 by P minus 1 by R. Always remember this thing, dear students. That is the end in your mind. So this is what you need to achieve. So that says that you need to bring P minus Q as well. You see 1 by P minus 1 by Q is there, no?
Yes.
That means what? That means if you make an simplification, PQ becomes the LCM and it will become Q minus P. So somehow you need to bring P minus Q here also in this expression. So how to do this thing? So that actually motivates you to make this thing that 2P by P plus Q minus 1, 2P by P plus Q minus 1 is equal to 2A plus P plus Q minus 1 into D divided by 2A plus P minus 1 into D minus 1. Correct. Clear or not clear?
Yes. Yes.
Okay, now let's simplify it. So if we simplify, in the left hand side, what we are going to get?
P minus
We
Q.
are going to get P minus Q by P plus Q. P minus Q divided by P plus Q. That if you simplify, you are going to get P into D P into D divided by 2A plus P minus 1 into D if you simplify. Okay. I'm sorry, that is a small mistake I have made it here. Q into D, not P into D. Correct, no? Because 2A plus PD minus PD will get cancelled, minus D plus D will get cancelled, QD. Yeah, this you will get. So this we give an equation number 1. In the similar manner, the sum of the first P terms is equal to sum of the next R terms. Correct or not?
Yes.
Similarly, what we will get that P minus R by P plus R should be equal to R into D by 2A plus P minus 1 into D. Similarly, as sum of the first P terms is equal to sum of the next are terms. So what we are going to get? From here we are going to get P minus R by P plus R. P minus R divided by P plus R is equal to R into D divided by 2A plus P minus 1 into D. All of you agree to me?
Yes.
It is just we are saying from the symmetry.
Mm.
Correct or not?
Yes.
So now let's dividing equation 1 by equation 2. That means in simple terms what I'm saying is that equation 1 in the numerator divided by equation 2 in the denominator in the left hand right hand side. Let me write properly. Equation 1 with equation 2. What we are going to get in the left hand side? P minus Q by P plus Q. P minus Q into P minus P plus R, correct or not?
Yeah. Correctly.
Divided by P plus Q into P minus R.
Yes.
All of you agree to me?
Yes.
That is equal to, we will get Q by R, right hand side.
Yes.
Since D is not equal to 0, because if D is equal to 0, question doesn't make sense. And 2A plus P minus 1 into D, that is also not equal to 0, then also it will not make sense. Correct, no?
Yes.
So now let's simplify it. Okay. So P minus Q into P plus R by PQ. So from here, what we are going to write, dear students? So from here, what we are going to get, this implies P minus Q into P plus R, P minus Q into P plus R divided by P plus Q into P minus R. Correct? That we already get. Now what we are going to get, let me simplify it further. Just a minute. So that means P minus Q into P plus R divided by Q is equal to P plus Q into P minus R divided by R. Correct, no? But what you need to achieve, always, start with the end in mind, that what you need to achieve. We need to achieve that P plus Q into 1 by P minus 1 by R. If you need to make 1 by P minus 1 by R, what you need to do is that we are multiplying both the numerator, both sides of the denominator by P. So then what you are going to get, here you will get P and here you will get P. Okay. Since P is not equal to 0. Correct, no, dear students? But why we have done so? Because that will give us that is actually taking us towards the result. So then what we are going to get is that in the left hand side, we are writing P plus R. In the right hand side, P minus Q by PQ. P minus Q divided by PQ. In the right hand side also, it is P plus Q. Got it, no, dear students? Are you getting my point, dear students? What I'm saying is that P plus Q into P minus R divided by PR, correct? So from here, what we are going to get? P plus R into 1 by Q minus 1 by P equal to P plus Q into 1 by R minus 1 by P, correct? No?
Yes.
So now you can make it, little bit of simplification to get exactly what has been asked for. If you see, what has been asked for is that P plus Q into 1 by P minus 1 by R. Correct, no? And that is equal to P plus R into 1 by P minus 1 by Q. So you need to interchange the left and right hand side and multiply both sides by minus 1.
Yes.
So what we are going to get here is that P plus Q into 1 by P minus 1 by R is equal to P plus R into 1 by P minus 1 by Q. Got it?
Yes.
Proved. Anyone have any question, please feel free to ask me. You can also look into it later and get back to me. Now let me go to the next question. The next question is find the sum of the first n terms of that particular series 1 into 2 plus 2 into 3. That was the last question, dear students.
Yes.
Okay. Anyway, in that, what about just I made the derivation? You can again look into it and you can always ask me later. Okay. But we should proceed. Otherwise, we'll not able to make enough coverage. Is this question done by everyone?
Yes, I do.
Okay. What about others?
Yes, sir.
Yes, sir.
Okay, great. What is the value you got, Gurman?
So I got n by 2 into 1.3 plus 1.1 n.
Yes, even
Yes, sir, again I got that one.
What you are talking about? I don't think it is correct. Your answer should be in terms of n cube, n power 3. Did you get it or not?
No, sir. Even I got n by 2 into 1.3 plus 1.1
N by 2?
into 1.3 plus 1.1 n.
Disha, what you got?
So even I got the same.
Okay. Let me do it actually, dear students. And then you can let me know. So what is your approach? Can I take someone of your solution here? If you give me, is it fine if I bring Sagnik, your solution, can I bring it here?
Yes, sir.
Okay, great. Then give me a minute. Let me bring your solution here and then let us discuss. So this is a solution, Sagnik, what you did, no? Dear
Yes, sir.
Sagnik, you able to view it?
Yes, sir.
Okay, so what we see is that 1.1 into 2, right? Plus 2 into 3. What you thought actually?
Oh, I thought it's 1.2 plus 2.3.
No, no.
Yes.
Then what will happen? It is not like that. Okay, if you have assumed, then what will be the last term? Tell me. N dot n plus 1, correct? Sum of the first n terms, no? So 1
I
into
didn't do
1.
it that way.
No. I think all of you have done this manner, no?
Yes, sir. Yes.
Is the common difference same? Let's take it is 1.2. You took the decimal point. What is the difference between 2.3 and 1.2?
1.1.
1.1.
And then 3.4 and 2.3 is 1.1. In that way, you started proceeding, right?
Yes.
No, sorry. Actually, the intent was not that. The intent of that question was not that. Think about, you need to think about if n is 100. Okay. Then 9.10 you'll write or what? Then how will make the difference? Correct, no? So the question was not that, dear students. It was not the intent for it. So what is that? Let me come back to let me tell you the solution. That is why it is so important to discuss the solution. So what is that series? If we find Sn is the series 1 into 2 plus 2 into 3 plus 3 into 4. In that way, it goes up to n into n plus 1. Correct, no? Now, you just apply, little bit of decimal, difference. You will not find that the common difference is same. Okay, not always. Okay, because you may find a number that where you need to carry to carry over. So just to make sure that the way you thought is may not be, it is not correct actually. So then what is the pth term? Let TP be the pth term. Is the pth term. Okay. So TP is equal to pth term. Then what we are going to get it is that. So from here, what we get, TP is equal to nothing but P into P plus 1. Na, correct, dear students? First term is what? 1 into 1 plus 1. Second term is what? 2 into 2 plus 1. Third term is what? 3 into 3 plus 1. In that way, Pth term should be P into P plus 1. Correct or not?
Yes.
So that is equal to what? So that implies Tp is equal to P square plus P. Correct or not?
Yes.
Clear or not clear? So what you need to do? We need to do Sn. So from here, we need to find the value of Sn. Sn is equal to nothing but sum of these P square plus P from P equal to 1 to n. If you understand this, symbol or not, let me know. Summation means what? It is a symbolic representation when there are multiple terms. Okay. For example, let me explain you here in a different color. Suppose you need to add T1 plus T2 plus T3 plus, in that way you need to go to T of 2000. Correct, no? So this representation you can also write as this is equal to summation of Tn, where n is varying from 1 to 2000. Got it, no, dear students? Hello?
Yes.
All of you got it? There is a symbolic representation. And another representation, let me tell you, if you see T1 into T2 into T3, in that way, into T2000 means all these terms are multiplied. That means I can write like this also. Correct, no? Then what will be the value, symbolic representation? It is a kind of a big pi. You write Tn, n is equal to 1 to 2000. That is for the product. So here it is sum, correct or not?
Yes.
So from there, what we are going to get? This implies Sn is equal to summation of p square, where n is equal to 1 to n, p is equal to 1 to n, p is equal to 1 to n, plus summation of p, where p is equal to 1 to n. Correct, no, dear students?
Yeah.
So from here, what we are going to get? We are going to get Sn is equal to, now let's apply these values. What we are going to get? P equal to 1, it is 1 square. P equal to 2, it is 2 square. P equal to 3, it is 3 square. So 1 square plus 2 square plus 3 square up to last term will be n square. Correct or not?
Yes.
Plus p equal to 1 to n, it is 1 plus 2 plus 3, right? Plus dot 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 up to n. Correct or not?
Yeah.
Now please recall
The
our
form.
discussion is that correct? That
And
sum of the squares of the first n natural numbers. What is that? It is n into n plus 1 into 2n plus 1 by 6.
yeah.
N into n plus 1 into 2n plus 1 divided by 6 plus n into n plus 1 by 2. Correct or not? So from here what we are going to get Sn is equal to n into n plus 1 by 2. You can take common, no?
Yes.
N into n plus 1 by 2. Just simplification. N into n plus 1 by 2 if you take common, then we are going to get 2n plus 1 by 3 plus 1. Correct?
Yes.
So finally we are going to get n into n plus 1 into 2n plus 4 by 2 into 3.
Yeah.
So that implies Sn is equal to n into n plus 1 into 2n plus 4 divided by 2 into 3. That is 6. Correct or not? So you can make little simplify, and what you are going to get Sn is equal to n into n plus 1 into n plus 2 divided by 3, and that is the answer. Are you getting the point?
Yes.
Absolutely clear, dear students.
Yes.
So this is the way to proceed, and it is quite understandable. That is okay, fine. At this moment, it is fine, absolutely fine at this moment. Okay. Then I just would like to touch base, the initial discussion of geometric progression I want to make. So I hope all of you have another 10 to 15 minutes, dear students.
Yes.
Okay, great. Because the last DPP, what I get, I realized after giving the DPP, yeah, in the second DPP, there are many questions from geometric progression. And hence, let's discuss that one, and then we'll proceed further. Okay, is it clear? All of you have some 10-15 minutes now? Sagnik, Disha, Srijita?
Yes, sir.
Okay, great. Thank you
Yes.
very much. Okay. So dear students, we are now going to start discussing the geometric progression. A sequence A1, A2, A3 and so on is said to be in geometric progression, or we known as GP, if the ratio of the consecutive terms, two consecutive terms, is equal to is constant. That means the ratio between A2 and A1, that is A2 by A1, should be equal to A3 by A2, should be equal to A4 by A3, and so on, and it has to be a constant. Okay, then we call this is in geometric progression. Means the sequence A1, A2, A3 is said to be in geometric progression, or GP, if an plus 1 by an is equal to constant for all n belongs to capital N. And if we assume that constant as R, okay, then this constant is known as the common ratio. So dear students, in case of geometric progression, there are two terminologies important. One is the first term, that is A, always like the arithmetic progression, and another thing is that common ratio R. If you make an analogy with the arithmetic progression, you found their common difference, correct or not? And here you find common ratio. So what are those? So first, in the first term, generally its symbolic representation is A, okay, and common ratio, okay, and its symbolic representation is R. So in case of just a side discussion, in case of arithmetic progression, the symbolic representation is like that. First term is denoted by A and the common difference is denoted by D. And in case of geometric progression, first term is denoted by A and common ratio is denoted by R. Clear, not dear students?
Yes.
Now, like arithmetic progression, here also we are going to find what is that nth term, what is the sum up to the first n terms, and all this stuff. But here we will find that things will get little difference based on the value of R, whether it is greater than 1 or less than 1. That restriction was not there in case of arithmetic progression. There is no restriction on the formula based on the value of the common difference in case of arithmetic progression. But in geometric progression, we will see there is a slight variation of the formulas based on the value of R, whether it is, different values of R. We'll see it actually. So the first thing is that, the very important point about that, the nth term and the sum up to the first n terms. So these are the two things is very important we are going to discuss on. So if we know the first term, that is A, the first term is A, and the common ratio R of a GP, okay. So let me give you an example. Sorry, I should actually give you some examples before proceeding further. Suppose one example could be 1, 2, 4, 8, and so on. If you see, in this case, that first term is 1 and common ratio is what, 2, correct or not?
Yes.
And you can get another one is that 3, 1, 1 by 3, 1 by 9, and so on. In this case, what you see, the first term is equal to 3 and common ratio. Can someone please tell me what is the common ratio?
In the 1 by 3.
Fantastic. Common ratio is 1 by 3. Correct. So then what we are going to get, so these are kind of a two, examples of geometric progression. So the first thing is that if we know the first term A and the common ratio R of a GP, then we can find the nth term of the GP is denoted by Tn as like this. Tn is equal to A into R power n minus 1, dear students. And here is not much restrictions on, there is no restriction, not much restriction. There is no restriction at all on the value of R to find the nth term. So I repeat, if we know the first term A and common ratio R of a GP, we can find the nth term that is equal to A into R power n minus 1. That is the nth term. And what is the sum up to the first n terms, dear students? That actually depends on the ranges of value of R. So first thing is that if the common ratio is greater than 1 or less than minus 1, the formula is A into R power n minus 1 minus R minus 1. Mind it, here it is R to the power n. Whatever the value you got, then you subtract 1 from that. It is R to the power n minus 1 by R minus 1. So this is the formula. A into, so what I'm writing, I can write also along while I'm saying. So it is Sn equal to, A into, it is R to the power n. First you find, then subtract 1, R to the power n minus 1 by R minus 1. When R is less than minus 1 or R is greater than 1. Correct, dear students? Now the second case is that, first case we discussed. Second case is that, apart from the case that R is not less than R, R is not less than minus 1 and R is not greater than 1. So then it would be R should be in between minus 1 and 1. So that case is that it is just, A into 1 minus R to the power n divided by 1 minus R. Okay. When minus 1 less than R less than 1. This case, dear students. But these are the two major formulas, by the way. Other cases, what I discussed, that is very, very corner cases. First, focus on these two. Now, second one we can get from the first one. Just multiply both numerator and denominator by minus 1. If you multiply both numerator and denominator by minus 1, you will get the second one.
Yes.
Correct, dear students? Clear? So what we is that Sn, that is a sum up to the first n terms, is equal to A into R to the power n minus 1 by R minus 1 when R is greater than 1 or R is less than minus 1. And for rest of the cases, that means when R is in between minus 1 to plus 1, then the formula is that A into 1 minus R power n by 1 minus R. These are the two major branches. Other thing is that if R equal to 1, that means, all the terms are equal, right? We can construct a geometric progression, something like this, dear students. I say I have a geometric progression, all terms are 1. Yeah, fine. Or you can say all terms are 1 by 7, 1 by 7, 1 by 7. Correct, na? That is, it is so obvious. In this is, you can say this series in arithmetic progression also, correct, now with the common difference 0.
0, yes.
Yeah, it is also in geometric progression with common ratio 1. So if you add up to the n terms, what will be? It will be the n into the first term. That's why n into a, correct, na, dear students? You see this is this case if R equal to 1.
Yes.
Okay, and rest of the two cases is that if R is minus 1, then what will happen? And if R is minus 1, then the sum of that first n terms will be depend on whether n is even or odd. If it is even, then it will be 0. Correct, na? 1 minus 1, 1 minus 1, like that. Correct, na? Did you get the point? Suppose we have a geometric progression where R is equal to minus 1. Suppose first term is 5. Correct, na? That is A is equal to 5. and common ratio R is equal to -1. And let's see, there are even number of terms we are going to add. So first term will be what? 5. Second term will be -5. Third term will be 5, na, dear students. Fourth term will be -5. Fifth term will be 5, and so on. Now, out of this, if you need to add, if n is an even number, that means what? You are going to add the even number of terms. Suppose you want to add these first two terms. Then what will be? 5 minus 5, 0, na?
0.
Or if you want to add the four terms, that's the next even numbers.
Still this.
5 minus 5, 5 minus 5, 0, na? Correct or not? But if you want to add the odd terms, suppose you want to add the odd term. So first odd terms is 5 minus 5 plus 5 is 5, na? That's why it is a the first term. Correct or not? Are you getting my point? All of you got my point?
Yes.
If n is an even number, the sum will be always 0 if the common ratio is equal to -1. And it will be a, that is the first term, if common ratio is equal to -1 and you are adding the odd number of terms, the first odd number of terms. Think about 5 minus 5, 5. If you want to add, what you are going to get? 5, no? That is the first term.
Yes.
The next one will be what? 5 minus 5, 5 minus 5, 5. Correct? Here also you add, you will get actually 5. Correct or not? 5 plus minus 5 plus 5 plus minus 5 plus 5. What is that? 5. Correct or not?
Yeah.
So the main formulas, dear students, the major formulas is this thing, what I marked in the double tick. The rest are the corner cases. Clear? Now the last point what I'm going to discuss. After that we will continue our discussion in the next class. But that is a very important one and we should discuss. Okay, another few minutes, dear students. Okay. Suppose, let me give you a practical example. That example also applicable to, in physics problem. Think about, you take a, rubber ball. Okay. You take a rubber ball and you drop in the floor from a particular height h. Correct, no? So this is the ball. From the point A, you drop it and it comes to the point B. So first what will happen? First you will come to the point B, na, dear students. After that, what will happen? It will bounce back.
Yes.
It bounce back, it will go up now. How far it will go? Will it reach A or will it reach less than A? The height A. It depends. Okay. What it depends on? Can you tell me? There's a little bit of discussion of physics as well. From the point A, if you drop a ball means what? You just actually, without giving any force, you just release your hand. That's it. You are holding the ball in the grip of your fingers. You just release the fingers. Then what you will see, dear students, now you will see the ball will drop at the point B in the floor. Then it will go up, but it will not reach up to the point A. It will be little less than A. Correct or not, dear
Yes.
student?
Yes.
Good man. Am I right?
Yes, sir.
Okay. Then suppose it come to the point. Suppose A1. Then again it will come to the same point B. Again it will go back and it will not come to the point A1. It will come to a little lesser A2, correct or not?
Yes.
And
Yeah.
in that way, that entire motion is keep on going. Hitting the floor, bounce back, 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 all these things. Now if you see this thing, that the height covered in each of these bounces, that actually belongs to a geometric progression. Correct, na? Suppose first is actually height was h. Correct? Initial height was h. Then next height is h1. That is the BA1. So h by h1 is equal to h1 by h2, where h2 is at BA2. Okay. That ratio is always less than 1. Correct, na, dear students? that if you find h1 by h, you will find that is equal to h2 by h1, and that is known as the common ratio in this case. Obviously, the value of h is more than h1, na, dear student. And when the denominator is more than numerator, we get the value less than 1. Correct or not?
Yes.
So what we get, dear students? What we get is that this is a practical example of a geometric progression where the common ratio is less than 1. And you know, dear students, there are many cases we'll found where things are in geometric progression, the situation is in geometric progression, where the common ratio is less than 1, and that geometric progression continues. And if you see here in this case, in a very ideal environment, if you make that experiment happen in vacuum, okay, if you release a ball from the point A, it is keep on bouncing, correct or not? Keep on bouncing. That means what? It actually in a geometric progression, in fact, very precisely to say, it is an infinite geometric progression with common ratio less than 1. So there are many cases, dear students, where the progression is an infinite geometric progression, or we can say infinite geometric series with common ratio less than 1. As it is a very practical situation, so we are going to discuss little bit about it before we actually conclude our session for today. So what happened is that, if you look into this one, if r is less than 1, let me devise this formula from this one. If r is less than 1, what is the sum of that infinite series? This sum of that geometric series is Sn is equal to, let me use a different color. Dear students, what I'm saying is that if r is less than 1, then what is the sum up to the first n terms? Which formula we'll take? We'll take this branch, na?
R is
A into 1 minus r power n by 1 minus r. Correct or not?
yes.
Clear or not clear?
Yes.
Now here, what is r? R is less than 1. Correct or not? Clear or not clear?
Yes.
Okay. In fact, when we say r is less than 1, very specifically to say, we can say here it is minus 1 less than r less than 1. Or we can say mod of r is less than 1. We'll discuss in details later about mod, then you will see. Mod of r less than 1 means actually minus 1 less than r less than 1. Okay. So then what happened is that if r is less than 1, dear students, means mod value of r is less than 1, that means it is a fraction, na? It is a proper fraction. For example, it is 1 by 3 or 1 by 4 or 1 by 5, like that. Now, if you make a power by a very big number, n is very big, na? Because when there are multiple iterations, infinite series, that means n is tending to infinite, correct or not?
Yes.
Then what will be the value of r power n? Should be tending to 0.
0. Yeah.
Correct, na, dear students? What all I'm saying is that if you make, r is less than 1, and if you increase n by a very big amount, r power n is going to be 0. So what I'm saying, as n tending to infinite, r power n tending to 0. When mod of r is less than 1, that is minus 1 less than r less than 1. Correct, no? Are you getting my point?
Yes.
So then, in an approximate sense, we can ignore that value. If r to the power n is actually going to be 0, then we can ignore that value, na, in approximate sense. So what is that value we are going to get then? So we are going to get S infinite, means sum of that infinite series, that is nothing but limit of Sn. Limit means it is a limiting value. No need to worry about this thing. Okay, n tending to infinite. That means limit of n tending to infinite into 1 minus r power n divided by 1 minus r. Acha, dear students, if you recall, we have done differentiation, we have done integration, we have seen that if there is a constant, we can take out of it.
Yes.
So here also from that limit, we can take that a and 1 minus r out of it, because a is also constant, 1 minus r is also constant.
Yeah.
So what we are going to get, a by 1 minus r, correct?
Yeah.
In limit of n tending to infinite 1 minus r power n, correct, dear students? Now r power n, as we just discussed, that as n tending to infinite, r power n is equal to 0. So finally what we are going to get, the value a by 1 minus r into 1 minus 0, correct or not?
Yes.
So what we are going to get is that sum of that infinite series is equal to nothing but a by 1 minus r. This is a very important one and it has a lot of applications. Now, if you go back to our discussions of that bouncing of that ball by releasing that ball from our fingers, okay, from our hand, okay, what will happen? How much distance it will cover? So it actually depends on what is the first term, means what is the initial height and what is the bouncing factor, correct or not? With that we can find it out. So just to give you the the relevant theory, after, as we have discussed, after giving the relevant theory, if I give the relevant theory, it goes something like this, okay? And you'll get it now about this particular theory here, dear students. So if the magnitude of r is less than 1, magnitude of r is less than 1 means what, dear students? It is mod of r is less than 1. Magnitude is a non-negative value, correct? If mod of r is less than 1, then we see r power n is tending to 0 as n tending to infinite. So we see that if the number of terms of a GP is very large, with magnitude of common ratio less than 1, the sum of the GP to infinite terms is actually infinite quantity and can be obtained as S infinite is equal to a by 1 minus r if r mod of r is less than 1. Correct, dear students? Now some of you may have little bit of confusion about that mod. What is mod? Mod is actually a non-negative value. We discussed earlier, if you remember, dear students, the mod of x is equal to 1. Mod of x is equal to x if x is greater than 0. And that is equal to 0 if x is equal to 0. And is equal to minus x if x is less than 0. Correct, no, dear students? For example, let's find the value of mod 5. If we find the mod 5, what is that 5? 5 is greater than 0. So it comes to the first branch of the definition, that x. That is why it is coming to x. Let's take a value of mod of minus 7. Minus 7 is less than 0, so it comes to the third branch of the definition. That is equal to minus of x. X is what? Minus 7. So minus of minus 7, ultimately it gets 7. Are you getting my point, dear students? So here it is 5 by the way.
Yes.
And suppose mod of 0, obviously it is x is equal to 0, so it's 0. That is the fundamentals about the mod. So with this, I'd like to conclude the class for today, dear students. And I'll let you know the DPPs, what you need to solve. Yesterday, I gave the DPP set 1 and set 2, dear students.
Set 3 and set.
I'm sorry?
So set 3 and set 4.
Set 3 and set 4. Just give me a minute. Let me quickly go through it. Set 3 and set 4. Set 3 and set 4 you are telling, no?
Yes.
Yeah,
But
yeah.
set
Set 3
4
and set 4. Yeah, yeah. I recall set 3 and set 4. Yeah. So let me quickly share the website www.KonarClasses.com, and I go to the login, and then go to the right online examination. Then you go to sequence and series 3 4 3 4. So definitely 4 you should do, and this also you should do. Okay, this is all related to GP. So 5, set 5 you should do, dear students. Okay,
Set 4.
set 4 and 5. Yeah, correct, no?
Yes.
Okay. All right. With this, I would like to conclude the class for today, unless you have any specific question or comments for me. You'll get the class notes in another 10 to 15 minutes, dear students. Okay. All right.
Thank you.
Thank you.